Hey mathematicians, now that we've gotten the inequalities written, in the previous video I'm going to show you how to use the graphing calculator to transfer them onto your paper. And first, I've got them typed, the first two inequalities from problem number 1 typed into the Desmos calculator. And as you can see, it's not really all that helpful. The first thing I'm going to need to do is zoom out, clicking the zoom button. And I'm going to drag my window so that I'm only focusing on the area that is in between the y-axis and the x-axis, because this is where all the positive numbers are. And that's all I really need, because we're talking about a real life situation where we're talking about number of hours, and we don't need to worry about negative numbers of hours because that's not a thing. So remember that it's easier if you graph your inequalities one at a time. So I'm going to click right up here next to my bottom inequality. I'm going to type that purple button to make it go away for now, but not actually delete it. And I'm going to look at what I've got going on right now. So my line for my green inequality hits the y-axis right here at 18. So I'm going to go over to my paper, and I'm going to put a coordinate right here at the 18, halfway in between the 16 and the 20. If I go back over to my calculator again, I see it hits the axis at 22.5. I did screw this one up. The graph only goes out to 20. Sorry about that, you guys. So I'm just going to kind of put it like just a little past the 20 to make it 22.5. As you can see, the y-axis and the x-axis, those end points are connected by a line that is a solid line, and that makes sense because there's an equal to sign underneath that inequality. So I'm going to click the line tool just because I'm doing this on ClassKick, or if you're doing it on paper, just connect them there with a solid line. And I'm not going to worry about the shading yet. When you're graphing a system of inequalities, that means 2 or more, we're really only interested in the shading after we've gotten them both down. So I'm going to wait and not do the shading on my paper yet. So now I'm going to get rid of the green. I'm going to click the button to get my purple one back. And I can see that it hits the y-axis at 20. So I'm going to put a coordinate right here at 20. I can see it hits the x-axis also at 20. So I'm going to put a coordinate right here at 20. They're connected by a solid line. So I'm going to connect it with a solid line. So now, this is what I have on paper so far. And to deal with the shading, I am now going to turn them both back on. And remember, when we're dealing with a system of inequalities, the most important part is where you see the two colors mixed together. So on this graph, it's going to be this dark purple, where you can see that the purple shading and the green shading have overlapped. That is the part that we care about the most, because that is where all of the coordinates are that satisfy both inequalities. That means that the coordinates that are in this area allow our person in our story to make at least $180, but work fewer than 20 hours at the same time. So I am going to just kind of color right in here. Actually, let me do a different color so that it shows up a little better. So I'm going to color right here in this little slice on my paper. And again, that little area represents where my solutions are. Now we need to use that little slice that I just highlighted where all the solutions are to determine an answer to this question right here. So remember, X represents our number of hours of babysitting. and Y represents our number of hours of hostessing. So we need to find an XY coordinate that falls right here in this little slice, because that represents a possible number of hours she can babysit and hostess, make the money that she wants to make while working the number of hours that she wants to work at the same time. So I'm actually going to kind of zoom in here a little bit. And it can be a little hard to find ordered pairs on Desmos sometimes. But hopefully you can kind of see, and I'm going to get my little, you can kind of see here along the x-axis, it gives you, you can see, even if you zoom in, it gives you the numbers that fall along the x-axis. So like right here, for example, oh, oopsie, that's not what I meant to do. Let's try that again. You can see like the 3 is right down here along the bottom. Why does it keep doing that? Okay, let me just try to graph it going up. Yeah, so here. So if I draw up, there's a 3 right down here at the bottom of the window that you can see. And I don't know, I'll pick this point right here. So it lines up with the 3 along the X. And then if I kind of like see where it lines up along the Y, it looks like it's halfway in between 16 and 18, which means that's going to be like 17. So that means the coordinate, the X coordinate of 3 and the Y coordinate of 17 looks like it's a solution, but I can use my Desmos calculator to make sure that that's right. So I'm going to click 3, 17, and I'm going to put it right there in the graphing calculator. And so I zoom in a little bit. Now, that coordinate does work. This is super duper duper important. This will work as a solution because you can see it's like right there on the edge of where the dark purple is. But the only reason I can use this solution is because it falls on a line that is solid. If this were a dashed line, I wouldn't be able to use that coordinate because a dashed line doesn't really exist. So honestly, I think it's a better idea to kind of get used to always doing one that falls like right in the middle of the shading. So I would make this a 16 to kind of bring it down so that it's not actually on the line, because that's safer. So that 316 does fall right there in the shaded region. So that means that one possible solution is that she can babysit for 3 hours of babysitting, and she can do 16 hours of hostessing, and she would meet her goal of making the money she wants to make while working fewer than 20 hours. Now, if you would please pause the video and go ahead and try to do the second problem. If you flip over your paper, you'll see there's another one on the back side. And I did goof on the second one again. I'm really sorry. I don't know why I keep doing that. One of your endpoints will go off of the graph, so don't think that you screwed anything up. But try to pause the video, use the Desmos to get your own graph, and then restart the video when you're ready to see whether or not you got it right. Alrighty, so hopefully you have in fact paused the video and now you're just ready to check now that you've tried it on your own. So I've got the 2 inequalities typed into my Desmos graphing calculator. Remember that this isn't very helpful right now, so I need to zoom out a little bit. And I'm going to drag my graph over so that only my positive numbers can be seen here, because we can't have a negative bag of chips or, oh, oops, I just realized I put that inequality in there backwards. They're both greater than or equal to. There we go. But remember, I just want to look at the part that is inside the Y and the X axis, because that's where the positive numbers are. I am going to turn off my purple one for right now. I see that I have coordinates that need to go for my green inequality. My Y coordinate is a 30, my X coordinate is a 60, and they're connected by a solid line. So I'm going to put a coordinate at 30, This is where I screwed up again, and I'm just gonna have to put my 60 like a little off the graph. And I'm connecting them with a solid line because it is an equal to. Then, so I got that part done. Then I'm going to click the button to make this one go away. Turn my purple one back on. I need to put coordinates at 35 on the y-axis and at 35 on the x-axis. So 35 is right here in between the 30 and the 40. And then I'm going to connect them with a solid line. So I've got that part done. And now to deal with the shading, I'm going to turn them both back on. I'm going to get rid of this for a minute. So remember, the part that matters is where you see both of the colors overlapped. Sorry, my window went a little crazy there for a second. And as you can see, because they're both greater than inequalities, both of them are shaded up. So the part where the purple and the green overlap to like make this darker purple, that is where all the solutions are. So on my paper, I just need to highlight this whole area here above the two inequalities. So this is the part that matters, where both of the inequalities like overlap. And so here you can kind of see that it looks about the same as it does on the graphing calculator. And so now I need to find a solution in order to represent one passable solution for X, a number of bag of chips, and Y, a number of sodas that would work for this kiddo to make his goal. So any coordinate that's up here in the shading. So I notice along the X coordinate, like it lines up here. If I just chose that one at random, it could have been any coordinate that's up here in that area. So it lines up with the 25 on the X axis and the 45 on the y-axis. So that means as an ordered pair, it would be 25, comma, 45. But just for good measure, I am going to double check by typing it into my Desmos calculator also. So 25, comma, 45. And yep, as you can see right here, that coordinate does fall here in the little darker area where all of the different solutions are. So that one will work for my inequality. So one possible solution is 25 bags of chips and 45 sodas, although you certainly could have come up with a different one. As long as it is up here in the shaded region, you are all good. And there you have it. There is problem number 2.